Here we want to estimate the integral of e to the x squared plus y squared over the rectangle R given by the range of x values from -2 to 6 and y values from 0 to 4. And in this problem we've told you how we want you to estimate that. We're going to split R into 4 regions and use the midpoints as our sample points. Well, let's start by just sketching the rectangle R. Just draw a rectangle, and what we're going to do is label the range of x values, which was -2 to 6, and the y values from 0 to 4. And to split it into 4 regions, we're just going to cut it in half both ways. And then that means that this y value here should be the average of 0 and 4, so that's 2. And this x value will be the average of -2 and 6, which is also 2. So those give you the 4 regions. And we want to find their midpoints now, because those are going to be the sample points that we use. And each midpoint again comes from averaging the x values that bound that little region and the y values that bound it. So for example, this one here, the x value is the average of -2 and 2, which is 0. And then the average of 0 and 2 is 1. So that's the point 0, 1. This will be the point 0, 3. Here's the point 4, 1. And then the point 4, 3. So now we've found our 4 sample points. So what do we do with those? Well, the idea here is that the double integral of some function can be approximated by a double Riemann sum. So what you're going to do is take f of all of those sample points, multiply by the width and the height of each of these little rectangles, and then add them all up. So in this case, delta x, that's the width of these rectangles. So from -2 to 2, or from 2 to 6. And they all have a width of 4. Another way of thinking about that is that's the same as the original x length. All the way from -2 to 6 would have been 8, but we cut it up into 2 pieces. And same thing with the delta y. So delta y in this case is going to be 2. And that comes because the original y length was 4, and I cut it into 2 pieces. And sometimes we abbreviate delta x, delta y by delta A. Right? So that's the area of one of these regions. And so since these regions are all 4 by 2 rectangles, the area of each region is 8. So what you're going to do is take f of all of your sample points, so f of 0, 1, for example, and multiply by 8. F of 0, 3 times 8. F of 4, 1 times 8. And finally, f of 4, 3 times 8. And you might have noticed those are all multiplied by 8, so we might as well just pull the 8 out of the whole thing. And then we just have to find f of all of those quantities. And remember, f is just the function that's sitting here on the inside. So in this case, it's e to the x squared plus y. So for example, f of 0, 1 is e to the 0 squared plus 1 squared. I feel a little silly writing the squareds, but let's go ahead. And then e to the 0 squared plus 3 squared, and so on all the way down. Well, in this case, our answer is just going to have some e's in it, and that's fine. Right, so this is going to be e to the first, and then e to the 9th, and then e to the 17th, and finally e to the 25th. And well, it doesn't get much simpler than that. So there we go. That's the approximate value of this double integral over that rectangle.